Welcome, everyone. We're just giving it a moment for all of you attendees to come in from the waiting room. Right. I still see some folks trickling in from the waiting room, so we'll just give it a few more seconds and then we'll get started. All right, I'd like to welcome everyone to this Linux Foundation Broadband webinar on building the intelligent broadband network, open source standards and AI in practice. I'm Dan Brown, Director of Communications at LF Broadband, and we are privileged today to have with us four fantastic speakers to dig into this topic. We have Bruno Cornelia from Vodafone, Manuel Paul and Bjorn Nagel from Deutsche Telekom, and Srikant Uludiria from Netsia. So thank you to all of our speakers for participating. Um, at any point during this webinar, if you have a question as a member of the audience, you are welcome to click the Q&A button in the Zoom interface and submit that question. We are going to get through the full presentation, and then we will take as many of those questions as possible within the time available. But you don't have to wait till the end. If a question comes up during the webinar, you are welcome to submit that at any time. With that, we're going to kick off just with a very quick introduction to LF Broadband from me for those who may not be super familiar with us. So LF Broadband is a nonprofit open source foundation under the Linux Foundation that was founded in 2023. We essentially support open source technology projects to transform broadband networks and the PON industry. Currently, we host two projects, VOLTHA and SIBA, that I'll talk more about in a moment, and these projects are in deployment. So you may be asking, why do we need open source technology in the broadband space? LF Broadband, as mentioned, is not only open, but also future-proof using a cloud-native architecture. We have projects in production again. These are multi-vendor platforms, so you can support a broad portfolio of vendors and are not limited to a single ecosystem vendor, leveraging multi-protocol centralized network management and SDN control planes. We are the only open and disaggregated solution in production currently. And these solutions have been proven in production to lead to significant savings, including both lowering CapEx through licensing costs and operational expenses as well. We are supported by a fantastic group of members, including Deutsche Telekom, Turk Telekom, Adtran, Netsia, Radisys, as well as our research partners in the academic space. And as I promised, a little bit more on our projects. Some of our speakers will be getting more into the technical details of these. But just to give you a high-level overview of our two projects, first, SIBA is a reference design architecture. And so this supports a variety of different virtualized access technologies at the edge of carrier networks. These include your PONs, your g-pons, and the like. SIBA is it's cloud native, built on open source Kubernetes. It's high speed, it's operationalized, and it serves as the foundational architecture for VOLTHA, which is our second project. So VOLTHA, also open source, is a project for PON broadband access equipment. And so this supports multi-vendor disaggregated broadband access as a service for central offices. It also provides an isolation layer between a vendor agnostic abstraction PON management system and vendor-specific white box hardware. So you're going to hear more about these projects and how they play with our partner, the Broadband Forum. So, folks who are participating here should know that this webinar was organized jointly with our partner, the Broadband Forum. And so to just give a very, very fast overview of the differences and the overlap between LF Broadband and Broadband Forum. Broadband Forum is essentially defining what the operators require, and then LF Broadband is delivering the working production grade code to support those requirements. We're going to dive more into a specific example of that today, WT525 specifically, which bridges CloudCO from Broadband Forum with SIBA and VOLTHA. Essentially, the goal of this partnership is to align standards with open source work in order to accelerate innovation in the broadband access space. So with that, I'm going to stop talking and turn it over to the real experts. And we are going to start with Bruno, who is going to discuss the evolution of CloudCO architecture and its alignment with open source platforms. So Bruno, over to you.
Thanks. Thanks, Dan. There was a need coming from almost more than 10 years ago for broadband operators to reduce cost and also to have a different approach where you have a more pay-as-you-grow solution, and also to speed up rollout of new services that was at the time being quite difficult. That's why that at the end a project called CORD, Central Office Redesign as a data center, was born. And but there was a clear understanding at that time when this was born that that was a great idea, but we need to have interoperable solutions, because you have physical element, virtual functions, controllers, orchestrators, and if you don't want to be strictly linked, tied to a specific vendor, you need to have all these components to be interoperable in order to be able for an operator to decide different vendors for the different elements. That's why the Broadband Forum decided to develop a CloudCO framework in order to create an interoperable environment. But there was something that we had to take into account. Was already available an open source solution in the market at that time. Next slide, please. So the idea was to build, and what was the basic concept that Broadband Forum used in order to create the CloudCO environment was to strictly divide network element, virtual function, controller, orchestrator, network orchestrator, service orchestrator, in order that each domain, each network element has its own functionalities, responsibilities, and will be strictly having a stack that will have which each element has its own, let me say, capability, and we will not need to have different solutions where the capabilities are in different network elements. So that's why was the concept where we based on. And next slide, please. And this is what we created at that time. It was clear that you have obviously the virtualized functions. You can see on the right of the picture on blue, where you have all the virtualized functions could be as a repository, can be based on Etsy Mano, or can be based on Kubernetes, so to have containerized functions. Then you have different, let me say, network functions let me say you can have the CPE, the access node, the aggregation, the edge, and all of them will have its own SDN controller. Each of them will have, for example, for access, you will have the virtualized functions, could be different management solutions based on BAA, for example. Then you have aggregation, edge, and all of them are managed by a CloudCO domain orchestrator that will refer to an end-to-end network orchestrator that will deal also to other, let me say, other areas that are not in the responsibility at the moment of Broadband Forum. For example, transport, domain orchestrator, but you can have also as a multi as a multi-service operator like Vodafone is, you have also mobile, for example, and so on. Then you need the end-to-end network orchestrator. You have FCAPs where you can have the FCAPs there and so on. You will have all the state of the network, everything. You will see everything. And then on top of that, in order to separate the network from the service layer, you will have the end-to-end service orchestrator. That is not in the responsibility of Broadband Forum. All of them will have, you can see they are linked together. For example, the access, you will have the MFC interface, that is flow control in order to disaggregate control plane and user plane. You have the MIF interface for management, the same for aggregation, for edge, and so on. Then you have interfaces that are defined between controller and orchestrator. You have interfaces defined between domain orchestrator and end-to-end network orchestrator and so on. This means that we define clearly all the level of the network, physical element, virtualized functions, controller, orchestrators, and network orchestrators and the service orchestrator. Next slide, please. Here you will see a simplified version of the architecture where you can see the access and edge only. You will see how the elements are divided. You have the functions, the virtual function in the DLT for the physical OLT, the DABNG control plane for the disaggregated BNG. You have the access controller, CCO, the CloudCO domain orchestrator, and end-to-end network orchestrator. You will see that for each interface, you will see the relevant technical report that will describe these interfaces. You will have for disaggregated access TR477, for disaggregated BNG TR459. For management interfaces, you will see that you will have for both access and edge, you will have the TR14. The interfaces between us, the controller, and the orchestrator, you can use TR411 or TR528 that define clearly the intent messages based on TM Forum ontology. Next slide, please. Here you will see, let me go how the disaggregated OLT is defined. You will see that the main functions that are disaggregated in the solution provided by Broadband Forum in TR477 are related to customer management. You can see ONU management, or access node management and ONU management. Then there are other network functions, for example, routing functions that are defined in the issue 2 of this TR. Next slide, please. And here you will see also how the disaggregated on BNG is defined in the TR459. You will have the disaggregated BNG control plane and the disaggregated BNG user plane. You will see the list of functions there defined, but let me give you some hints what are the main functions that are disaggregated. You see here the complete list, but customer management again, low flow intercept, traffic steering, QoS control, and many others. But let's see that these are the main one that you will see disaggregated in the BNG. Next slide, please. So we are at the end of this presentation. It was clear that in my presentation there was a need to redesign the fixed broadband in order to have a more efficient and cost-effective solution. And so more than 10 years ago, the core project was born. But the main problem that the core project had at the time was to define the interfaces at the border of each element in order to have an interoperable solution. So the Broadband Forum decided to develop the CloudCO framework and to specify all the related interfaces in order to have a complete interoperable solution. Broadband Forum also decided to define the interfaces for disaggregating both OLT and BNG in order to fit with core requirements. The main C that we will see in the next presentation is how we will introduce the already existing open source VOLTHA into a CloudCO framework. Thanks a lot for your attention.
Thank you, Bruno. And now we'll turn it over to Serkant, who's going to walk us through the details of WT525. You're muted, Serkant.
Yeah, okay. I think we are good now. Thank you, Dan. Hello, everyone. I want to start with a quick observation. VOLTHA is in live production today at Deutsche Telekom and Türk Telekom. These are tier 1 operators running real traffic, and this project is not a pilot, it's not a proof of concept. And this deployment shows actually open source has genuinely made it into the carrier network, and I think this is a big deal. But here's where things get interesting. Also, Bruno touched those points. The more of this deployment scale, the more you bump into a new kind of problem. It's not a technology problem, but an operational one. The question is, how do you manage a massive multi-vendor network with the consistency that a carrier actually needs? That is the gap that WT525 is designed to close, and that is what I want to walk you through today. So aligning VOLTHA and BBF class CO architecture. So in short, this WT525 is a working text document in the Broadband Forum that is formally specifies how VOLTHA and Broadband Forum standards map to each other. You can think of it as the translation layer between the open source world and the carrier grade standards world. On one side, you have VOLTHA, the open source disaggregated OLT stack. It's moving fast, iterating constantly. And on the other side, you have the Broadband Forum CloudCO framework from TR477. That is the architecture that defines how a carrier grade access network should structured and managed. And the challenge is these two worlds were built somewhat independently, and if they don't speak the same language, you end up with integration headaches every time any vendor shows up or a new feature you develop. So WT525 defines formally where the interfaces align, where there are gaps, and what needs to happen to fully interoperate. So it's not a vague alignment document right now, it's a concrete technical specification as a working text. Next slide, please, Dan. And when we look at the details, WT525 covers 3 layers of architecture. At the top is the northbound API interface. This is the interface between your orchestration layer and the SDN stack. WT525 maps the SEBA northbound interface directly with the CloudCO, OCCO, NFSDN access interface. That is the interface how your OSS systems actually talk to the network. And in the middle, it is the SDN management and control layer. It mapping the SEBA network edge mediator to the equivalent access SDN MNC blocks in CloudCO. And this is where the subscriber management, device control, all of that logic lies. And at the bottom, and honestly, this is the most complicated part, and most of the hard work is. It is a southbound API site. VOLTHA uses OpenOLT, gRPC, whereas BBF specifies netconf with YANK modeling. These are obviously different protocols, but critically, both share YANK for data modeling. That's a common data model that allows us to disaggregate OLT to look like a set of standard logical blocks to the orchestration layer. So that's regardless of the vendor underneath, doesn't matter. If we can get these layers, 3 layers aligned, and then we have a real end-to-end interoperability. Next slide, please. Now, I want to talk about why this alignment matters for AI, starting with telemetry. There's a simple rule in the AI world. If you put garbage in, you get garbage out. And in legacy vertically integrated networks, that garbage problem already baked in. If you had 3 OLT vendors, you had 3 completely different ways of reporting something as fundamental as optical signal strength. Building any kind of network-wide AI intelligence on top of that is nearly impossible. And because you can never give the AI a consistent picture of what is happening in your network. And WT525 tries to fix this at the foundation by mandating common YANK models across the stack and mapping telemetry through the standardized MIF BBF interfaces defined in TR-477. And then you get a single unified stream of data regardless of what hardware is sitting in your deployment. And once your data is consistent and your AI becomes trustworthy, you can train models that actually generalize across your network. And you can build like digital twins where the virtual replica stays in sync with your physical network. And we can switch to the next slide then, please. And the pillar 2 is closed loop automation. Historically, network operations were reactive and manual. Your management systems, of course, could see a problem, but then a human need to log into a CLI, he needs to figure out the fix and need to push that fix. If you are running a network at a carrier scale, that is human in the loop is a real bottleneck. And WT525 tries to enable a standardized pathway for AI to act, not just observe, because the SDN-MNC layer interfaces are now mapped and predictable across the stack. An AI agent can send instructions down using a common language. It doesn't matter if the underlying hardware is a white box royalty or a traditional vendor chassis. The instruction looks the same. In practice, the loop is like this. The AI detects a service degradation using that unified telemetry stream that we talked in the previous slide. And it sends a standardized instruction to the SDN-MNC layer. and then the network automatically reprograms flows or make other adjustments like changing the ONT power levels. And then the telemetry from that fix feeds back into the loop to confirm it's worked. So that is an example of a self-healing network. Next slide, please. And the third pillar is about the northbound. That is where you actually talk to the network. Today, configuring a service means a technician writing specific CLI commands, knowing VLAN IDs, priority bits, etc., all the implementation details. And intent-based networking changes that. Instead of specifying how, you now specify what. And the slide shows a simple example. Let's say you want to provide low latency gaming traffic during evening hours. That is your intent. And the AI layer translates that into standardized MBI calls, and the SDN layer executes this hardware agnostically. And here is the part that I think matters most for long-term operations, because the northbound interface is standardized through the WT525 alignment. That intent stays valid even when the underlying stack changes. You can upgrade your hardware, you can upgrade your software, like you can change your VOLTHA version, and your business level policies stay same. And that's an important alignment. Next slide, please, then. So, in summary, bringing it all together, WT525 creates the runway for AI for VOLTHA. 3 pillars: unified telemetry gives the AI consistent, trustworthy data. Closed-loop SDN gives the ability to act autonomously. And intent-based networking lets operators drive the whole thing from business goals rather than configuration files. But the one thing I would want you to take away today with you is this: AI models are highly sensitive to inconsistent inputs in a multi-vendor environment. That inconsistency is your biggest enemy. If data varies from one OIT to the next, your AI model will be unreliable, and you cannot get correct responses from your model, how your sophisticated algorithms you are using. And WT525 is the work that fixes that at the foundation. It is what makes open source agility and carrier grade standards actually compatible with each other. And it accelerates what we can build on top. Thank you, everyone. And I would encourage anyone interested in details to reach out to both Linux Foundation and Broadband Forum to join the work. Thank you.
Thank you, Serkat. And now we are privileged to have Manuel Paul, who's going to talk through some future opportunities for AI-driven broadband networks.
Yeah, thanks very much, Dan, and hello all. Obviously, AI and broadband. So AI is just a key topic everywhere, and we could actually look all across and would see so many opportunities. Now, looking at the enablers that Serkan and Bruno have previously identified, we are not starting from scratch in broadband networks with existing standardization and open source initiatives. So for Linux Foundation Broadband, the board and the organization and our community, obviously right now we are looking into what are the key areas the strategy should focus on for LFBB and our partnership with Broadband Forum. So looking at the many areas of opportunity, which many we have already touched upon, which first and foremost is optimization when it comes to actually designing, building, and even configuring the network, up to the opportunity to automate with even self-healing and a much more autonomous operation. The strategy needs to start and focus on where can we take advantage, where can we leverage existing standards, and where actually can we put in place, like previously has been happening with the origins of VOLTHA and CBA, open source implementations that prove those standards, but also even go beyond and address operators' use cases and provide reference implementations, and moreover, through exemplars, then deployment grade proof of concepts and commercial implementation basis. So looking at the areas that are coming at this point as first up and in focus for the fund and for the collaborations, the advantage of taking standards, building on top, which includes on the northbound side APIs that allow to interact with the orchestration and application level, as well as enable agents and agentic AI to be operationalized in the network with MCP service and relevant protocols. So those don't have to be reinvented, and there's a lot already emerging where LFBB can build on top. Now, having that said, there's a focus to enable end-to-end level network API. There is more than the access network, and LFBB with particularly the CBA architecture and reference design includes services that stretch from the customer, all those different kinds of services, up to the service edge, and also allow for the selection, the steering of so-called access sessions to different service edges. So here, QS and quality experience come into play, and a lot is possible there. So second area of focus, but obviously there's a lot that can be done within each domain, and we are looking particularly here at the disaggregated access network domain with the FTTH and also still existing FTTB networks. Going forward, the focus is to enable the use of AI, particularly in those domains, and building on top of the telemetry and open data interfaces that are already available. Now, going to the next slide, please. Where actually do we think AI creates value? And I already said it's a promise. It's more than that. It's an opportunity for operators and the industry at large, all across board. However, the four key areas LF Broadband is looking at are network optimization and intelligence, which extends from predictive maintenance and predictive also closed loop automation to tackle events and tackle faults in the network, but moreover going to dynamic and more personalized experience management, so that services actually can respond faster to network conditions and to application requests. That being said, it needs the level underneath, the access network, to be empowered, and there's a lot more that can be done in the access network itself, having the opportunity to look at OpenOMCI with all of the data coming in, performance data from the ONUs, seeing events happening and doing actually a recognition of such events in a much more differentiated way than today's pretty still like manual intense efforts at some point. So automating and avoiding human intervention is the goal. And the second category where we can actually unlock more value and looking at infrastructure and efficiency, fiber planning and split. This is obviously optimizing demand and actual resources underneath in the network. The key focus for LFBB is looking at where can the infrastructure be empowered and where can the FTTH PON network be more energy aware and enabling in this regard to not just look into each OLT or access node, which handles a certain aggregate, but couple this to intelligence that allows to see the service requirements and the actual traffic load being matched, and so that the network actually behaves much more according to the current demand rather than running at always on. And last but not least, category 4 for value creation is the home and the edge. So very important with regards to the end-to-end perspective. And I think here we are looking at pretty much extending CBER and the reference design in those areas where edge and inference via service edges and next generation gateways can do a lot more than today. But having that said, on the home network side, there is a very, very huge opportunity due to the scale to CPEs, looking at the need to bring the services and the quality actually in front of each customer and each application to their eyeballs. So that being said, not all cases are economically same mature or already determined as viable. We are looking at working together as a community to define the high value ones, identify pain points, and look at where do we need to go beyond and improve existing interface specification standards, put them together and put them at work for better automation, and do so at scale and across a multi-vendor landscape. This is very, very key for operators. Next slide, please. Here, a lot has already been said, so I'll just summarize on why Linux Foundation Broadband is ideally positioned and ready by design for that demand. Obviously, we have standardized telemetry, open source based functions and tools built in with standardized message buses and open source interfaces that really allow for a multi-vendor and multi-model, multi-technology access network to derive telemetry and to improve dynamical adjustment of the configuration across those open interfaces. So looking at a programmable network, next slide, please. There is from an origin of the SDN principles, a goal to allow for the automation, which in the end means there is an enablement for closed loop automation. So this concept is not new to us, but we are now looking at actually a much better understanding that comes on top with AI to detect certain interference patterns and allow for a much more intelligent and differentiated identification of events, so that the actual self-healing as a key example in a closed loop workflow can happen increasingly without humans in the loop and with a true closed loop automation. And next slide, please. So with that said, from the AI assistance to autonomous operations, and that's an important theme all operators worldwide are working on, I would suppose, and I'm sure for my own organization and industry partners and other organizations we are in touch with. We are looking at bringing the automation up to level 4 and above. In order to do so, we need to move from today's AI-assisted diagnosis and the early day AI, which is already very, very helpful and efficient, to a near-term, more autonomous and policy-driven, policy-bound operation. So that means going from a really human-driven to a certain pre-approved remediation automation, taking humans out of the loop. And while LF Broadband at this point looks at the real world, which means operators are really in charge of providing a reliable and bulletproof network. So there is obviously a recognition that this this evolution will take time and will also need confidence. So why does VOLTHA help here? Well, VOLTHA provides confidence for the deterministic APIs that are built in. There is great auditability and operator visibility and control over what happens. And so these insights have actually helped to get us the confidence with SDN, not just in the early days, but even for new use cases and features today and for the future. So we are looking at achieving and driving the same maturity and a certain learning curve with the collaboration in open source. And going to the next slide, please. For the operators, and this is now principle also where I think the segregation and the origin of why we are actually coming together and have standards, and why do we have open source that is very synergistic with standards. Operators need procurement confidence. So I talked about the confidence to having the opportunity to automate without actually being able to allow and afford for any failures or any hallucinations. So when we look at AI, we need a future-proof, but also a very reliable network operation. And this will be actually the point where interoperability in a multi-vendor system remains key, and visibility and assurance is the major theme for operators when we look at such a multi-vendor disaggregated world, which obviously at this point, Linux Foundation Broadband already has brought us to great confidence. And so we're looking forward with AI to move into the future and to reap those benefits. And at this point, also I do invite further operators, other industry partners, interested parties to join us on this evolution track and on this way forward. Thanks very much.
Thank you, Manuel. And now we'll turn it over to Bjorn to bring us home, discussing disaggregation and the values and challenges for operators and vendors. Over to you, Bjorn.
Yeah, thanks, Dan, and thanks all the others. And hello, everyone, from my side as well. Yeah, now let's have a look on what is already reality of that. We heard a lot of standards about theories of transitions and so on, and now I will give you a little view on what we have already available in reality. So first of all, a quite generic overview about the transition, where we are come from, and where we want to end up. What you can see here is easily that we remain, or that we stay with the same OSS BSS platforms. That is not touched in this transition, and we remain with a multi-vendor strategy on the OLT side. But what we have in between we have, or we try to achieve these improvements and which are promised by the standards and by the solution developed. So we are reducing the effort of OSS integration. We are doing it just once, not for each and every vendor silo again. And then we are using not different management systems to manage and control the OLTs in that vendor silo. We try to establish, or we establish, an open source based control and management framework that is not a monolithic part or a monolithic thing. That is a framework composed by different small components or smaller bricks from different suppliers combined and brought together in a hyper collaborative activity to create these open source based management and control framework to manage all the abstracted OLTs underneath, which still come different from multiple vendors and have to be integrated here. The integration effort is quite lower than we had it on the OSS BSS platform, and less complex, of course. And on the ONT side, there's already a certain level of compatibility established and interoperability, but that we try to make it even simpler and less complex by not using the vendor-specific OMCI stack on the OLTs. We have a virtualized OMCI stack established in the VOLTHA framework, which communicates with the different ONTs, and that, from our perspective, makes the interoperability between that single network-oriented virtualized stack and the ONTs at the customer side much easier. So next slide, please. That is what we are having today is we have deployed that in live networks. So mainly, as already mentioned from Serkan, we see that in Türk Telekom network as well as in a DT network. We have some more live establishments or live deployments in Geo and Vivo. We have a lot of subscribers already connected to VOLTHA and CBA based architectures. We will see that in two examples later on. You will find brownfield as well as greenfield approaches in that. And what is for all the same is that it still have these multi-vendor aspect in mind, and it is still aligned to standards and definitely based on cloud native deployments. So, and additional to these live networks, can you click once, please? Additional to that, we see a lot of trials and proof of concept and lab activities globally. So now next slide, please. So the first use case I would like to explain a little bit more in detail is, of course, the case we are hosting in Deutsche Telekom. It is a brownfield modernization on, at the end, national scale, of course. What we had in the past, as I mentioned, from an operator perspective, it is crucial to have a multi-vendor strategy for your hardware suppliers. So that means today we end up with multi-vendor PON silos. Even if we create this kind of interoperability on the ONT side already in our legacy networks, but on the OLT itself and the managing instance of the OLT, we have these vendor-specific silos, and that comes with relatively high OSS BSS integration costs because we have to repeat that from every silo to every silo. These are the main pain points we would like to overcome, and there the solution yeah, the solution is based on the VOLTHA CIBA activity hosted by LF Broadband. And there we create a vendor agnostic abstraction of the OLTs, and we build up an architecture which is composed by the CIBA 2.0 architecture, which includes the service edge or former BNG functionality in the whole picture of our access network. And the abstraction of the OLTs, of the northbound, directly northbound of the OLTs, that opens the market from our already installed gray box OLTs up to the usage or the opportunity of using white box OLTs and or white box OLT ecosystems in our network. Of course, the first focus was on further usage of our installed base. We have already an installed base, therefore it is a brownfield modernization case. We have an installed base of OLTs, and these have to move from the legacy architecture towards the new world by abstracting the OLT at the northbound and getting rid of the vendor-specific management plane. So where we are, what are the outcomes? We established a fully automated zero-touch provisioning process. So that means only the fiber and the cable installation and the power installation for the OLTs is still needed on site, and every management and provisioning and configuration process afterwards is running fully automated without any operator invention needed, yeah, that is one big step we achieved with that transition. And another one is, that was a big achievement, and a big challenge was for this brownfield scenario, the migration of the already installed OLT base from the BNG towards the Access 4.0 point of delivery, and that has to be done because that, of course, is a service interruption for the customer. Therefore, we have to do it in the maintenance window at nighttime, and that has a high level of requirements in terms of automated processes, because even or especially in that time frame in the night, we don't want to have lots of human intervention. So that has to minimized, and we are quite close to finalize our preparation for the migration. And of course, we addressed the aspects of reducing CapEx and OpEx, even if it is not listed here, and licensing dependencies, which are one of the big headaches for operators. So I copied a quote of Fabian Schneider into that slide. He is a super squad lead of our Access 4.0 program developing and engineering. That is the activity where we are hosting the development part of this transition. So there are, of course, in an operator environment, there are more people involved, more divisions involved for the migration, for the build-up process and everything. But for the development, we have that here. So please click maybe more than only one. Go ahead. Stop it here. So that is the Access 4.0 end-to-end network as we build it now. So we have the components of service control and backbone, and OSSIT, as already mentioned, will stay the same as we are using today. And then we created close to these OSSIT a central management layer in a Kubernetes cluster, which is a single management instance. Okay, these are two instances, of course, for some security cases, but effectively it is a single instance, which is for the whole network. And then we are deploying these point of deliveries at 900 locations nationwide over Germany. And these are composed by a leaf spine fabric. The spines acting as a label edge router, and the leaf switches acting as a service edge functionality. Service edge for our retail and wholesale customer base, for private consumers, as well as for direct fiber connected business consumers. And of course, we have a leaf switch for a wholesale connection. And the management and control framework, the local management and control framework, is installed on a local server cluster, which is installed in these 900 locations, of course. And the OLTs, MSANs, and all other access components are connected to remote locations and connected to that architecture, where we run all these applications to achieve these targets of disaggregated architecture, using open APIs, and build up a solution based on standards. Yeah, that's what we have in DT. Now we can go further, thanks to the second use case, which belongs to the Turk Telecom use case. The problem statement here is more on the service innovation, on the limited flexibility, but for the solution, you will find the similar approach. Building a solution based on the VOLTHA and CBER architecture developed in ALFBB, and growing the OLT ecosystem in a way that it is open for white box OLTs as well. So here we have also a significant number of customers connected, and it's a still growing number of customers which is connected to that network. We have, as well as we see it in DT, a measurable CapEx and OpEx reduction, and we have the cloud-like agility in the access network. The full case study you can find under the link on the slide. And now we can see on the next slide the architecture. It is based on the real fundamental disaggregation story, that you disaggregate an OLT into different components, into the OLT component. In the first step of VOLTHA, we focused on pizza box OLTs. Right now, the development is going further, and we are able to address chassis-based OLTs as well. But yeah, there you have the pure OLT function on these boxes, and then you disaggregate the control boards to an edge data center where you are running virtualized applications for Mac learning, for DHCP, for the virtual OMCI, as I mentioned already, and you have the adaptations for the different OLTs as well. So then let's go to the next slide. There are just 4 highlights of the latest VOLTHA delivery. So the latest VOLTHA deliveries are not so much focused on features anymore, because we brought a lot of a hell of new features in the very beginning of that journey. And right now we are more focusing on production-driven enhancements. So that means better fault isolation for ONUs. So we introduced the plumb level disable and enable feature. We improved the observability for future PON technologies like XGS-PON. Here we brought more statistics, more performance monitoring into it for XGS-PON. We reduced the operational disruption for OLT updates, and we brought a better control plane visibility via gRPC statistics across the VOLTHA services. All that is new in the 2.15, released in February this year. Feel free to check it out on the LFBB site. There's a full list of the enhancements of the new VOLTHA release and even for further releases. You can find it there. Let's go to the next. Okay, here we have the key takeaways. So that is what you have heard at the very beginning. There's a broadband network transformation which has reached maturity. We see it in live deployments right now. And these live deployments are further growing on with more and more customers connected to that. And both examples I presented here are based on VOLTHA-enabled solutions. So we heard a lot of AI opportunities on these platforms from Manuel already. And service provider now have the opportunity to access solutions with a vertical stack composed of open, disaggregated, and multi-vendor technologies. Yeah, these are the key takeaways from what we are seeing right now already in live deployments. Yeah, feel free to join us on that journey. Feel free to join us in the open source broadband access community or in Linux Foundation. You can influence real deployments, bring in your requirements into the open source stack and align standards with working code. And of course, as I mentioned, shape AI-ready access networks. Yeah, thanks everyone. That's all from my side. And now back to Dan for the Q&A.
Thank you, Bjorn. And I know that we have gone over time a little bit, so apologies for that. But we do still have our speakers here. So if anyone would like to submit a question, we don't actually have any pending right now. So we can give it a minute if anyone has anything that they would like to submit. Otherwise, we can wrap things up. All right. Well, I will thank once again all of our fantastic speakers for the great presentation today. We hope that you all found it valuable. This was recorded, and we will be sharing the video link out on the LF Broadband website tomorrow. So please do keep an eye out for that and feel free to share it with your colleagues. Thank you all again for joining us, and we hope to see you again soon. Take care.
Take care. Bye-bye.
Thanks,
you. Bye.
everyone. Bye-bye.
Thanks, everyone. Take care.